Hello everyone. In this video we're going to be talking about approach procedures. In particular, the different type of approach procedures we have in terms of precision on the one hand, right? Precision or non-precision approaches, and straight versus circling approaches. Let me get back for a second to our figure, right? We have already covered the start phase. And now we are moving into the whole approach procedure, right? From the initial approach fix down to the threshold, to the runway, or eventually initiating a go-around procedure, a missed approach. Well, before going into detail explaining each of the segments, I wanted to elaborate a bit about the difference between these two guys and these two guys, which has to do with the precision non-precision character of the approach. Well, when it comes to precision approaches, I'm going to do it on red, right, to be consistent. Precision approaches, we are talking about an instrumental approach that is providing both vertical and lateral guidance, it is based on ILS, right, instrumental landing system, typically, right? So if you see ILS in the chart, this means this is a precision approach capable of providing lateral guidance with the localizer, remember, and vertical guidance with the glide slope. The gradient is 5.2% or minus 3 degrees. This is the same gradient that the glide slope is gonna define in the procedure. And in these precision approaches, we talk about FAP, final approach point. So it is a point, it's not a fix. And we talk about decision height or altitude to initiate a go-around procedure. We will see more on decision height, altitude in next videos. When we talk about non-precision approaches, these guys are just providing lateral guidance, right? There might be based on just the localizer of the ILS or VOR or an NDB, right? Providing radial that is aligned with the runway. And here we talk about final approach fix, right? And miss approach point to initiate the go-around procedure. So these are the distinctive elements of each of the approaches. We can see them, right? Here, this is a precision approach, Madrid Barajas Adolfo Suarez, ILS, Whiskey for runway 32. We have some information up here. I don't care much about it. Here we have Tobec. Remember that we were analyzing the star meeting traffic towards Tobec, but you should know that there are other initial approach fixes, such as Asbin, right, with other star charts merging traffic towards this point, right? And here we have the different phases. The initial approach, right, would be initial segment would be this one. Then we have the intermediate fix, this VOR. Here, this would be the intermediate segment, and we will be reaching the FAP, the final approach point, which is defined with specific coordinates, right? We have latitude and longitude, and also a distance from the DME of the ILS, right? 6.2 nautical miles, as you can see. What else do we have? you see this shadow in here, right? This shadow is giving you the lateral kind of area in which you should be flying, following the localizer frequency that you should have tuned in your onboard aircraft. And if we go here, down here, you also see this vertical shadow area that is providing you the area in which you should be following a glide path of 3 degrees, right? As provided by the glide slope frequency of the ILS. If you see that the rate of descent, as I was anticipating, is 5.2%, corresponding to those minus 3 degrees. As we were seeing, you have here information, right, on the FAB to threshold distance for different ground speeds, different times, and the conversion, right? Remember, from a given gradient, we have to fly depending on the ground speed. What is the vertical speed you should have in your onboard your computer, right? We have more information right here, which we will analyze later on. Also, we have information here that we will analyze later on. Now, I just wanted to point out these particularities of the precision approaches. We have again in the vertical chart the FAB, the decision height or altitude is linked to this, okay? These altitudes, right, or heights, within brackets are heights with respect to ground, without brackets are altitudes, are providing decision heights, altitudes, depending on the category of the ILS, depending on the category of the aircraft in terms of speed. We're going to see this later, okay? So this is for a precision approach chart. If we go to a non-precision one, in this case based on the localizer, same runway, 32 left, Madrid Barajas. Now here we see again shadow area because it is providing lateral guidance. We are using the localizer. We have here the missed approach point and the FAF, right? You can see it also here, right? We have defined the FAF and the missed approach point, which is defined as 1.1 nautical miles from the distance measurement equipment of the ELS at a given altitude. If you're following a slope that is not 5.2, is 5.5%, right? So it's a bit kind of steeper. And the go-around procedure is defined with a 2.5% criteria, which we will see, right? But this, as you know, this is the minimum climb gradient 35 aircraft must be able to fly with engine failure, and this is defined to avoid any obstacle that we might find in the go-around procedure. So we have FAV mapped the gradient, which is different, and we don't see here any vertical guidance, right? So the vertical guidance is not provided. In principle, we should fly with our own means, right? In principle, we will be checking this information, right? How far are we from the DME, from the threshold, and what is my altitude, the actual altitude I have on board the aircraft, compared to these altitudes or heights that I am supposed to have if following the gradient, the given gradient 5.5%. Similar with VOR non-precision approach, nothing changes, but the fact that now I am supposed to be following a radial, right? So a radial 145 is defined with respect to Barajas, and I should be following that radial. I am not engaging the localizer at the autopilot, which makes things a bit easier. I need to follow a board navigation procedure that is providing lateral guidance. The definition of the FAF is here. And again, the map and the FAF are defined in a similar way, right? Here is the different conditions, an altitude and some distances, and here the rate of descent is 5 is different, right? But in general, again, we don't have vertical guidance, but our own flying skills. Now, if when it comes to the difference between straight and circling, straight is the most typical one. Precision approaches are straight approaches, and most of the non-precision approaches are also straight approaches, because this means that the final approach segment is aligned with the runway head, with the runway center line. In a precision approach, that's clear. In a localizer approach, it's also clear. There might be some non-precision approaches in which it's not fully aligned, but if I am within, so for the precision approaches, always straight, and for non-precision approaches, if within 30 degrees from the center line, right, then it's considered straight, right? I will need to turn a little bit, but it's considered to be straight. Circling is a way of a sort of visual approach in which, because of typically obstacles in the surrounding, mountains, orography, we cannot actually have final approach segment aligned with the runway or within those 30 degrees, and then I need to somehow make the approach in a turning way. It might also be the case, so if I am out of those 30 degrees for non-precision approaches, or if the gradient is greater than 6.6%. If that is the case, right, then it's also filtering, because it's quite maybe quite dangerous, right? So, for instance, we can see an example here. That's Pamplona, in which you see here that we have defined the FAF is the Pamplona's board, and here we have the map, right, defined at this NDB. So it's where you need to initiate a go-around procedure following this dash line, and how to fly from the final approach fix to the runway is not defined. You have to do it on your way. You have to establish visual contact. You see here that we have some obstacles, right? So we cannot actually come from this direction. We need to use this corridor in here, and then this is a circling approach, in which you see that here there is nothing. Here there is nothing, and I am a bit on my own as a pilot. So thanks very much for your time.